This video is intended to show how it is possible to calculate noise in two separate control systems operating side by side. This data comes from a study done by Dr. Ron Berger, studying the normal eye's behavior with refractive states from 0 to +2 diopters. What was calculated was the ensemble. In any event, here are the critical values. For the two eyes added together, you get a value of about 0.2 volts RMS or 0.2 volts. I'll now show the left eye. Notice the value is 14 RMS. Of course, there's variation there. See, I said left eye, and here is the right eye. Again, the voltages are 14 pretty much for both eyes. The total is about 18 or 0.18 volts or 0.18 RMS. Here's the basic concept. The right eye has a certain amount of noise. A left eye has a certain amount of noise. In this case, I had 0.11. What I showed was 0.14. The combination of the two then is a summation. In this case, 0.16. There is variation there. The calculation is right eye plus left eye equals the differential, all squared. And for reference, watch the video, a summary of the dynamic eye concept. That will give you the general idea of what is being done here. The concept of ensemble is deeply embedded in statistical mechanics. Here's the electronics that created these voltages. Total gain is 100,000 for each line. What you're seeing is the thermal noise or random noise of the input circuit of the 324. A DC blocking capacitor is used, and the output is some summation of two inputs. So the final output, which is what you see on the oscilloscope. Here are the gains: 100,000 RMS noise, 0.14 of each left and right eye, and the total gain voltage is 0.1 RMS. Again, the way to calculate it. Here's the DC circuit, which is a 9-volt battery divided by two 10K resistors, with the ground being +4 volts, or 324 ground. In any event, this is a good way to calculate noise in a control system. And this is a good way to calculate it. There's many other calculations and many other experiments which show this. And it's a good way to determine a value which is very hard to measure. So you need the analysis and you need the control system concept. I thank several people for this work: Peter Green and Antonio Medina, and particularly Ron Berger, who was a very great help in all of this. Thank you.